Hi guys, and welcome to another video. Today we're going to be looking at a video on tree diagrams and a question that appeared in a past examination paper. Now when it comes to tree diagrams, it's very important for you to understand this rule for exhaustive events. The probability of A plus the probability of not A must equal to 1. And this rule also applies to events that are complementary. Now, let me explain that very quickly to you. In a factory, 3 machines, A, B, and C, are used to manufacture plastic bottles. Now, this means that the plastic bottles cannot be manufactured by any other machine besides A, B, and C. So therefore, the probability of A plus the probability of B plus the probability of C must equal to 1. And that's what exhaustive events mean. So let's get on with the question. These machines produce 20%, 30%, and 50% respectively of the total production. 1%, 2%, and 6% respectively of the plastic bottles produced by machines A, B, and C are defective. So it says represent the information by means of a tree diagram. Clearly indicate the probability associated with each branch of the tree diagram and write down all the outcomes. So let's firstly start by, in a factory, 3 machines A, B, and C are used to manufacture plastic bottles. So therefore the tree diagram is going to look like this. So for 6.1, that's machine A, machine B, and machine C. And machine A produces 20% of the plastic bottles, machine B 30%, and machine C 50%. So therefore let's write it as a decimal. So 20% will be 0.2, 30% will be 0.3, and 50% will be 0.5. Then it goes on to say that they produce 20, 30, and 50% respectively of the total production. 1%, 2%, and 6% respectively of the plastic bottles produced by machines A, B, and C are defective. So therefore, for machine A, we'll say D for defective, and we'll say ND for not defective. Now they tell us that of machines A, 1% is going to be defective. So 1% represented as decimal is 0.01. Therefore, not defective will be 0.99. Remember, I spoke to you already about exhaustive events. So if you add up 0.01 and 0.99, it must give you 1. Now for machine B, 2% is going to be defective. So therefore, defective will be 2%, which is 0.02, and not defective will be 0.98. 0.02 plus 0.98 is 1. And for machine C, once again we'll have defective and not defective. And defective is 6%. So that will be 0.06. So this will be 0.94. Now that is our tree diagram completed. So let's just now put our outcomes at the end. So that will be A and defective. And this will be A and not defective. That will be B and defective. That's B and not defective. C defective. C and not defective. So therefore we have a total of 1, 2, 3, 4, 5, 6 outcomes. Now let's answer our questions. It says a plastic bottle is selected at random from the total production. What is the probability that it was produced by machine B and it is not defective? So if it's produced by machine B and not defective, it would be this option here. So machine B and not defective will be this option. Now remember that there's only one machine B and only one option is not defective. So we have to now follow this down to the root. So therefore, machine B and not defective, machine B and not defective will be 0.3 times 0.98. So we need to multiply out the probabilities. So for 6.2.1, the probability of B and not defective will equals to 0.3 times 0.98, and let's see what that is equal to. 0.3 times 0.98, and that's equal to 0.294. 0.294. So we can round off to 2 decimal places and write 0.29. Let's leave it in 3 decimal places. 6.2. What is the probability that the bottle is defective? The probability that the bottle will be defective, let's go look at the outcomes. So we got a probability defective there, A and defective, we've got B and defective, and we've got C and defective. So therefore, there's 1, 2, 3 outcomes where the bottle would be defective. So therefore, now we have to follow this down to the root once again. And then we have to multiply each branch 0.2 times 0.11 plus 0.3 times 0.02 plus 0.5 times 0.06. And then that will be our probability of a bottle that is going to be defective. Let's write that down. So for 6.2.2, the probability that a bottle is defective is going to equal to, let's start from here, 0.2 times 0.01 plus 0.3 times 0.02 and one more, 0.5 times 0.06. Now let's put that in our calculator. 0.2 times 0.01 plus 0.3 times 0.02 plus 0.5 times 0.06, and that's equal to 0.038. 0.038, and we'll leave that to 3 decimal places. You could have rounded off to 2 decimal places, which will leave us with 0.04, but I'll leave my solution like that. So once again, learners, that is how we answer an examination type question on tree diagrams. If you haven't subscribed already to JL Maths, please do subscribe, and I'll catch you in the next video.